So reviewing the equations for the different graphs, the linear one was y equals mx plus b. Inverse was a over x. Okay, so something over x. Direct was y equals mx. And notice the difference between linear and direct. Linear has a y-intercept and direct does not. So that's the only difference between those two. And then parabolic, a lot of you guys put y equals x squared. That is correct. On your test, I'm going to go ahead and have that extra little variable in front of it as well. But anything x squared is going to indicate a parabola. Okay. Now we're going to do it where I'm going to draw a sketch of a graph, and you're going to tell me which equation matches the sketch. So for this one, which equation is that going to be? So on your test, I'm going to have a question, and I might give you an equation, and then you get pictures of graphs, and you have to match them up. Okay. So you won't have to like handwrite and fill in an equation. There'll be a matching portion of it for you. For our next one, bless you. Try that one. So on this one, there was no y-intercept. So your plus b, it was plus 0. It's just y equals mx goes with that one. Okay? Yeah, it'd be plus 0. So.
No.
What about that one? So on that graph, as the x value increases, y decreases. They are opposites to each other. You should have the inverse equation. So it's just going to be something over x. You're looking for that fraction. This is the one that's got a fraction in it. And our last one was that. Good. Everybody got that one. That was y equals mx plus b. Okay, so that had a y-intercept. So again, on your test, I'm going to give you either the name of the graph, the equation, or a picture, like a brief sketch, and you have to match them all up together. Okay, so be able to put which equation goes with which picture. Good?
Good.
Okay. On our next part, I'm going to give you an algebra review worksheet, and I am going to go through a few of them with you. So if you have a pen or pencil and or you need to get one, go ahead and do that while I pass those out. You're going to do numbers 3, 5, and 9 together. Okay. And just so you know, I picked random equations from throughout the whole year, so eventually we're going to work with all of these. So some of them are a little more of a preview, and they're kind of more advanced, so that's why I'm going to go over those with you. I'll pick the easier ones for your test, okay? But again, we're going to start out with number 3. So on number 3, you'll see that wavelength symbol. This is the Greek letter lambda. It looks like an upside down Y. Kind of looks like a two-legged giraffe. Okay, so it's just a Greek letter. Treat it like any other letter. Okay. And then the rest of the equation looks like this. Okay. So first, you want to see if you can cancel out anything and simplify that. Do you notice anything you can cancel? Okay, good. So we can get rid of the L's. Okay. So that's going to leave us with wavelength over W times the sine of the angle. And in the question, you're asked to solve for just the angle. That's the Greek letter theta, the 0 with a line through it. You cannot just divide by sine. Okay, it doesn't work that way. With your trig functions, the opposite would be the inverse function, which is the like sine to the minus 1. We did that a little bit with tangent. But what you would do is multiply both sides by the opposite sine function. So we're going to multiply both sides by sine to the minus 1. Okay. So what that does is it's going to leave us with inverse sine. So on your calculator, you hit the second and the sine button. And then those two variables that were over on the left, you just leave them. Okay, and just put your parentheses up. So you're taking the inverse sine of that whole thing. And then whenever we take the inverse sine of sine, that's what cancels out. and it leaves us with just the angle. So your final answer is going to look like that. And I know in some of your math classes, you would flip and you would have the isolated variable over on the left. That's fine. You're welcome to switch those. I just got to this point where that's the only thing left. Okay. Make sure it's isolated. The only thing similar you'd have to do on your test with this one is in your triangle, you might have to find an angle, and you can use sine, cosine, or tangent, any of those inverse functions to get you an angle depending on which legs you're using. So if you need help with that later before you go home today, make sure you ask, and I can make sure you're typing in your calculator okay. The next one we're going to do together is number 5. And number 5 looks like this. There's a bunch of r's in the equation. And this is actually going to be one of the very last chapters that we do. The r's stand for something called resistance, and it has to do with electricity. Well, when you have more than one object that's describing the same quantity, you put subscripts on it. So that just lets you know it's the same type of thing, but for different objects. So, for example, like if I had 2 cars and I was looking at how fast they were going, I would have like car A and car B. So I would say velocity for car A would be v with the subscript of an A, and velocity for car B would be v with the subscript of a B. Okay, so whenever you have something with subscripts, that doesn't mean you can cancel out those big letters. They are different, so they're actually completely different quantities from each other, so we can't just cancel. Okay. On this one, we're looking to find RA. It says solve for RA. So what I'm going to do is take the thing that's not RA, and I'm going to get rid of it and move it to the other side. Okay, so on this one, that means I'm going to end up subtracting the 1 over RB fraction, and that's going to leave me with the RA. So all I did was subtract that fraction over from the one I wasn't looking for. So I left the 1 over RA by itself. Now at this point, some of you guys might be tempted just to take the inverse and flip everything over. You can't do that. It's not going to be RT minus RB equals RA. It doesn't work that way because you have fractions. So hopefully after we review this, it'll kind of jog your memory a little bit. What we're going to do is find what's called a common denominator. Have you done that before? Vaguely, long time ago maybe? Kind of ran out of room there. So find a common denominator. Since we don't know what numbers go in for those, we're just going to multiply those 2 terms together. So in the denominator, we're just going to multiply the RT and the RB together. And then to figure out what goes on top in the numerator, we're going to do this sort of cross-multiply type of thing. Okay, so I'm going to take RB and multiply it by 1. Okay, so RB times 1. And that's going to leave me with an RB in the numerator. Okay, because look, just kind of imagine if you, oh, I didn't mean to actually erase that. So if you were to imagine the RB here and the RB here, they would cancel, and that leaves you with 1 over RT. So it's still a way to find an equivalent. And then whatever sign you've got in between those in the step before, that's the sign we're going to write in the numerator. So they were subtracted, so we're going to subtract. And then we're going to cross the other way. So now it's going to be RT times 1, which is going to be RT. And I'm going to rewrite that on the next slide so that I can have it up at the top of the screen for you. So I'm just rewriting what we had before. And all of that was still